And let's continue with question 2. All right. The desalination plant is actually built at these coordinates. Okay, so basically this is M and this is N. If the desalination plant stops working, Tasmania needs to get to the plant in the minimum time. He runs in a straight line from his camp to a point XY on the riverbank. All right, so let's just go back to, I'm going back to the graph now. It's actually a little bit inconvenient. So we have a point at around square root 7/2. So this is going to be the desalination plant. I'm going to just use the same point so that it's not too confusing. So let's just assume that this is square root of 7/2, and I think it was 3/4. And in order to fix it, he needs to run from camp to a point XY. Now I don't know where it could be up here, it could be down here, but let's just say that the point XY is down here. Well, it's parallels that's unintentional. So this is the point XY, and this is run. He's going to run from his camp to this point, and I'm just going to read the question from a piece of paper here because I don't want to go back. And then he is going to swim up the river to the desalination plant. So he's going to swim here. So that, let's say that's swim. Okay. He runs from his camp to the river at 2 kilometers an hour. So the speed of running here is 2 kilometers an hour. And the time that he takes to swim to the plant is proportional to the difference between the y coordinates of the desalination plant and the point where he enters the river. Okay, that's interesting. So you need to show, if we go down to part C again, you need to show that the total time taken is given by this expression. Okay, so show that the time taken is here. Now, essentially what's going on here is you have two events. He needs to run and he needs to swim. So I'm just gonna tackle one of them at a time. So for the running part, you know that the speed is going to be 2 kilometers an hour, and the distance of running, it's going to be the difference between the point. So the difference between 2 points, or between the distance, sorry, why did I say distance? Distance is between, I was like, that's not making any sense. Between x, once again, if you look at the answer here, it doesn't have y in it, so I'm going to write y in terms of x and the point of the camp, which I think was 0, 0. Okay, so we're going to find the distance between that. It's a little bit annoying, I have to keep going back and forth, but if you look at the diagram again, then we're looking for this distance between 0, 0 and xy. Okay, so that distance is going to be, which is, so square root of, wow, look at that. Let's try again. Square root of x squared minus 1 square plus x squared, which is the same as, so again, I'm going to use a cas here. Just expand. I wonder whether if I just type this in, that is going to work. So x squared minus 1 square plus x squared. Alright, so if you just type it in, it expands for you and simplify. So x to the power 4 minus x squared plus 1. That's really good because if you look at the expression that you need to make, this is appearing. So the square root go back now. So the running time, it's going to be distance over speed, which is going to be a half of this. So that's the running time. That's 4 square and plus 1. Okay. Now the swimming time, I don't like this part of the question. I think it's a little bit clumsy, but you need to basically the swimming time is proportional to the difference between the y coordinates of the desalination plant and the point where he enters the river. So this difference is going to be, the y coordinate of the desalination plant is 3/4, and the point where he enters the river in terms of x is x squared minus 1. Now if you expand the brackets and simplify it, then you get 7/4 minus x squared, which means that the the swimming time, if you write it in terms of so proportion, so k is a positive constant of proportionality, then it will be k of 7/4 minus x squared, and the t total, it's going to be the running time plus the swimming time, which is a half of, this always happens, you know, I never understand why, just an issue. But anyway, I'm just gonna go down. Alright, so we would have a half, that's supposed to be a 1, of x to the power 4 minus x squared plus 1 plus k 7/4 minus x squared, and I think if you simplify it you would get that. So if I just take the 7 out, I'll just do that. If you take the quarter out, sorry, yes, take the quarter out from the second expression, then you would get a quarter k, and inside is 7 minus 4x squared. Okay, so that's show that it is shown. Alright, and then some other maths we have, if k equal to 1/2√13. So what I'm going to do, I think, is I'm going to define t in the cast. So we define t of x is nice, is a half. You don't want to use 0.5 in this case because it is going to give you decimal answers, which may still be in exact form, but still. So square root of x to the power 4 minus x squared plus 1, and then plus, I think I'm just going to write k over 4, there's a quarter of k, times 7 minus 4 times x squared. Alright, so this is expression. I'm not going to put what k in just yet, so you could do it here. So one way to do it, I think you can just do this, given that does this work? I can't remember. 1 over 2 times, we'll see. I think with the cast, you had to kind of play around with it because there are a lot of things. Alright, so this is t of x. Now if I type it again, yep. So this is one way to have a k value substitute into t of x. So this is t of x in terms of k. I need to find the derivative. There's no way I'm doing this by hand. So I'm going to define the derivative of t in terms of x, which is again going to be t of x here. Okay, so dt is this mess. Okay, what is this? So dt dx is, I can't even see. So I'm just gonna write my answer because I did this question already and I have the answer here. Actually no, this is still in terms of not k. So you, okay, what you can do is just put the k in. You could have just defined it. I don't know why I didn't do that. 2 times root 13. Alright, let's try again. Alright, so this is what you would get. And so that's x bracket 2x squared minus 1. And then 2 square root of x to the power 4 minus x squared plus 1 minus square root of 13 x over 13. This is what I've got for I. Hence, now hence is important because hence means you need to use the answer from the previous part. Find the coordinate of the point where Tasmania should reach the river if he is to get to the desalination plant in the minimum time. So again, we're going to find the stationary point, show that it is a local minimum. So I'm going to solve for x when dt dx equal to 0, and this should give me, let's see how many answers. So dt of x equal to 0, we're solving for x. Again, 3 answers, negative square root of 3. Okay, so you have x equal to plus or minus square root of 3 over 2, or x equal to 0. I'm just going to do a quick, I don't know what you need, honestly, for 2 marks. I tend to go overboard with my working out instead of under, especially if you have enough time. So dt dx, so this is root 3 over 2. I think root 3 over 2 is going to be the answer. It can be negative, and it probably can be 0, but if you just want to check, you can put probably a half, and I'll go with 1. So this is 0. Let's do another dt dx 0, and this is t, so a half. So dt of a half, I don't do 0.5 now because I really just make the size negative. Dt of 1 is that positive? Yep. Okay. So dt of a half is negative, and that's positive. Sorry, less than 0, so negative. Greater than 0, so positive. So it looks like that. So you definitely have local minimum. That's not even spell local. Local minimum at x equal to root 3 over 2. And we need the coordinate, so we just need to find the y value. So y will be just square this minus 1. So 3 over 4 minus 1, which is negative a quarter. Okay, probably should have given more room. So the answer is square root of 3 over 2 and negative a quarter. So that part. On one particular day, the value of k, so this means that k is no longer 1 over 2 root 13, is such that Tasmania should run directly from his camp to the point 10 on the river, so x equal to 1, to get to the desalination plant in the minimum time. This find the value of k. So this means that when x equal to 1, dt dx equals to 0, and you need to solve for k. I think this is really easy. You can just use the CAS. Now I need to basically remove this k value because my derivative of t is now defined with k in it. So I think I'm just going to delete k as a variable being defined. That's one of the many ways. There's a few ways to do this, but I'm just going to do that. Actually, that doesn't work. K is not. Does that work? You know, I sound really, oh, no. Okay, in that case, we need to go back and redefine, I think. Maybe I just define this. Can I redefine k? You know, there is a way to actually delete this. I just can't remember what it is. So I'm just going to define dt of x again. Okay, maybe we define this again. I think we define t, potentially it would work. So if I just go up and redefine, what does t look like now? Nope. Also have to redefine dt. Okay. Let's try one more time. Good, now it has k in it. So dt of 0, 1, sorry, it looks like that. And you just need to solve for k. That's supposed to be 1 equals 0. Stationary point, solving for k. K is a quarter. That's nicely done. So I'll write something down as well because the questions were more than a mark. So dt dx of 1 is a half minus 2k. So when dt dx equal to 0, a half minus 2k equal to 0, and then you would get k equal to a quarter. Okay, so that's good. Find the values. This is a good question. Find the values plural, so more than one, of k for which Tasmania should run directly from his camp towards the desalination plant to reach it at minimum time. So you still want minimum time, which means that you still want dt dx to equal to 0. I'm just going to go up to the picture again so we can have a look at what it means when you run directly from the desalination plant. But anyway, let me check. Sorry, I just need to get this one more time.